We already finished our module 1. Okay, in our module 1, there is several objectives that you need to achieve towards the end of our class. You can see here what you're going to learn is in terms of numbering. So this one you'd already learned in digital logic if you still remember, but our term of numbering here is much more advanced. There is a lot of format that you need to memorize, because like if it is 32, what kind of format? If it is 64, what kind of format? It is different between fixed numbers and floating number. There will be also a difference between each other. So I guess it's much more complicated compared to numbering system that you learn in digital logic subject. Okay, please enable your webcam so I can see your face. Now, under our introduction 2.1, in terms of arithmetic and logic unit, this one, just a question, no need for me to share with all of you. But we can see here, we start with our examinations of the processor with overview of arithmetic and logic unit, which is your computer arithmetic. This is the functions of your ALU. This is needed for you to do the arithmetic or like a mathematical problem. The rest, please enable your webcam. Later on, I'm going to ask you a question, okay? Then, computer arithmetic is a commonly performed on 2 different types. This one no need for me to explain anymore, because you know, in terms of our numbering system, 0, 1, 2, 3, 4, 5, you have the difference between integer side and also after your radic point, it will be different, which is we call as a floating point. So this you need to divide together, similar what you have done last time in your digital logic. If you want to convert from like decimal to binary, binary to decimal, there will be a different way if it is integer, and if it is floating point, you need to have another way, isn't it? So similar also in our computer, our ALU need to do different things to our floating point and to our integer. In both cases, the representation chosen is crucial design issue and is treated first, followed by the decisions of arithmetic operation. So here is data type. We have fixed and floating point. You can see here a lot of things, but for fixed number, you have all. You can see here, you have all. Tambah tu lah, darab bahagi, addition, subtraction, multiplication, divisions. But for floating point, in our COA subject, it's just focused on addition and multiplication. Okay, you're going to have several apa several technique. You need to memorize the technique. If you don't know how to memorize, you didn't understand and memorize the flow, you cannot answer the question. In terms of representation, this one is easy for you. You already know how to represent the number. But if it is playing around with unsigned and signed number, after this, okay, if I didn't share the module 2 yet, the e-learning, not yet.
Yes, betul.
Okay,
Not yet.
if you go and see, you're going to see, what is this? There is a lot of things because last time when you are dealing with your digital logic, you still see the 0101. But here you're going to see sometimes it is required for you until 60 bits. So it's quite long. Okay. I just share you what you're going to find out. You can see sometimes if for 32 bit, what happened? There will be quite long for you to remember. There is a lot of way. Although you can see it is a numbers that quite familiar with you. First complement, second complement, but it's slightly a bit different for your computer. You're going to see also there is several format that you need to remember. Okay, this one is like more to mathematical. This one is very important. Every year, every SEM, this kind of question will be coming out. So you need to remember. Normally we are very good and good-hearted lecturer. We help you and we provide you with this flow chart. You just need to know how this flow chart need to be followed. Okay, no need for you to remember, but it's good for you to remember. You can see this for multiplication. For division also, you're going to have a flow chart, but it's quite different. Okay, you can see this in your digital logic subject. You're just doing the multiplication and then you get the result. But in COA subject, it's slightly different. You need to have shift to the left, shift to the right, what all these table that you need to follow step by step. If, okay, if you know, because you know, right, this one, alhamdulillah, 2 times 3, you know the answer, it is 6. Correct, right? This is 6 for the answer. You can directly put the answer here. Let's say for 6 is 0000. Apa I dah lupa dah. Okay, let's say this is 6 in our binary. Okay, this is 6. But inside this, if your step is wrong, you also will get, of course lah, wrong. If let's say this one is 5 mark, I think it's more normally like 8 or 10 marks for just this one question. So every single detail here, it will provide like 1 mark, 1 mark, 1 mark, 1 mark. So if you wrongly fill in, then you cannot get the marks. You just get might be 1 mark for this part. Okay, so it's quite challenging for this subject related to this what we can format that you need to remember. Okay, this one is in term of still. Okay, I want to show you the division. Okay, this is the division part. You have a flow chart. You need to apply this. Quite similar, right? But there is a lot of different. Okay, let me proceed back to our things. Okay, where is it? Okay, now we have the LLU and we know already, okay, last time in our module 1, my lecturer already informed me that under my CPU, I have ALU, I have control unit, I have register. She informed me that I'm going to go detail one by one. Now you look at the ALU first. You know the function of LLU now, which is related to the aromatic problem. when you are dealing with your mathematical things and etc., numbering, so you will depend on your LU. You can try to look and read all the sentences here. We go directly for our numbering system. So we have, first of all, we're going to look when you have a number 197012, let's say. This will be what we're going to look into, 2.2 and 2.3. Okay, and the left one after radic point. Okay, at the left radic point, it is all a fixed number. Okay, this is the overview. Unsigned number and signed number. You need to remember this one is fixed number, but you still need to know that whether it is a positive, negative number or it is unsigned number. Let me look into the easiest part first, which is about our binary number first. This is not the new things for you. Binary, by mean 2. By bukan maksudnya you gay. Apa lagi satu? Gay, tak gay, gay tak gay. So this one is binary in term of number, but you need to know it is 2. Okay, base 2. And you still remember that if it is base 2, whatever number you have, base 2 need to have only 0, 1. And we always use this for our machine language. That's why our computer only recognize 01, 01, 01. We have only this for our base 2, and whatever number we times with our base, and we have a power of what? This one we have learned in digital logic subject. For those, okay, last time I teach space. Okay, space. Space is a part-time student. Some of them did not have digital logic background. So it's very hard for them to move in the module 2 because module 2 normally related to numbering. For those who thinks that you already forgot about numbering system, go back and look your digital logic notes, okay? Because it is always correlation. Similar also, or COA subject, it is very good for you to have higher knowledge because later on OS subject, you still need this knowledge, okay? It's all correlation between each other. Now you can see here, this is the format. If I didn't show you this format also, you will know because you already learned in the digital logic. And in terms of numbering, we always start from left to right, right to left, right to left. Start 0 and increase from 0 to the left, left, okay. From here to the left. This one also important. Okay, after I finish this one, please just memorize. Maybe you can just directly write in your notes. 1 nibble, 4 bit. 1 byte, 8 bit. If you said, okay lah, nantilah after class I will try to remember this. Then later on when you want to apply, because there is a lot of question that we relate to this, then you just okay, muka surat berapa? Oh, muka surat 11. It is at the 11 pages. So you try to look back. Okay, oh nibble, it is 4 byte. Then it's going to hard for you. Okay, so fill in your small note, maybe just memorize it directly. Okay, let's we see what is 4 bit. Last time we know, like maybe we have 1010. This is 0. 1, 2, 3, 4 means that 4 bits. And our numbering normally we have like a certain gap here. We have another 1010. Let's say 5, 6, 7, 8. Normally, we have this number. We call is 1 byte. Okay, 1 byte we have 4 bits. Okay, 1 byte we have 8 bits, and it's also equal to 2 nibbles. Sometimes in question, we as a lecturer don't know what equation that we want to give to you. We just like playing around with those things. Maybe we said, okay, the addresses, what you know about addresses, later we'll look into. Okay, the addresses are having 2 nibbles. Then suddenly, mana lah nota? Where is the notes that about nibble? This is going to be important, okay? Kilo, megabytes, this one is you know already, it's but not too hard, but this one is important. And after this, not only this, okay, maybe you say, alah, nibble dengan byte je ke, lecturer ni suruh saya hafal. But after this, you're going to have word, double word, apa lagi? Double word, F word, and etc. This is important because if you don't know how long one word is, one word means 2 byte, okay? Then you cannot put your answer in the addresses correctly, especially when you are dealing with the storage. Okay, that is always a problem for the student. Okay, now, as mentioned just now, the most important, saya tengah record kan? The most important is jalan ke tak in progress. The most important, the easiest one, which sign. Unsigned like easy, but we see first at the sign extension. Okay, here we have example 2 in 8 bits. You kena tulis 2, which is 2. You need to show it in represent it in term of 8-bit binary to 16-bit. Senang je kan? You ada 8-bit, altogether 8 bits. You just represent it in 16-bit. But this one, it is positive number. Remember digital logic subject. That's why I said that there is a correlation. If it is positive, you're going to put in front what? 0. If it is a negative number, what you need to put in front? Negative. Okay, so this one is all negative. So that is the difference between our positive and negative. This one is just a recap. You can see here, recap from your digital logic. Alhamdulillah. Okay, in terms of integer, this one we already know. Unsigned, signed, we have a whole, which is integer part, and fraction. Similar to sign, we have sign, magnitude, complement. This we already learned in your digital logic subject. Still recap. If you can't to understand all the notes here, you can refer back to your digital logic subject. It's quite complete. Rather than here, because it's just a recap, just pick which one is important. So under unsigned number, still remember what is LSB, what is MSB? LSB least, MSB is most. So it will be here M, it will be here LSB. Okay, so LSB and MSB. Bit 0 is our LSB, bit 31 is our MSB. And in terms of range, this one is for 32 bits long, so you have this range. While for the sign number magnitude, my phone. The conversions we have so far present have involved only positive number just now. And if you are doing in terms of negative number, it's going to be under sign magnitude. And the high order bit, which is the leftmost, we call as MSB. The remaining bit content of the value. This also you learn in the digital logic subject. Okay, this one is using sign magnitude for 8-bit binary. 1, 2, 3, 4, 5, 6, 7. And then you're going to put your magnitude here. If it is positive, you put 0. If it's negative, you put 1. Look back in your digital logic subject. 0 represent as positive. And look back on your magnitude. Okay, sign magnitude format. Sign magnitude format, you just apply in front as a sign number. Okay, why? Why we need this? Similar to why we need that in our digital logic subject, because we don't want to have overflow, because we don't want to have error where we are adding, subtracting, multiply, divide in terms of our numbering. I think this also been mentioned last time in your digital logic subject. Why you need all those like sign number, what else? First complement, second complement, why we need all of this. So this one is example using sign magnitude. Add bit number 1, 2, 3, 4, 5, 6, 7, 8. This one, okay, put positive. 8. Okay, you can see here, it adding everything here, and then last carry overflow is discharge. Maybe you can think back, what is the methods over here that it will discharge, whether it is first complement or second complement or just for the sign magnitude. Is it need to discharge for the first or discharge the carry? So it's mentioned here you need to discharge, but you're going to get an error. That's why when it's coming up an error, you cannot just focus on sign magnitude. Later on, you need the first complement, second complement. Okay, that is the thing why we show you the example on getting error and on getting the overflow. Okay. This is all a problem. Okay, this is a problem using a sign magnitude similar. Just a recap for your digital logic subject. This is all the problem. That's why we will have later on the first complement, which one complement and second complement. I don't want to go in deep because this is all that you have done in your digital logic. Chapter 2 also in the numbering system. Okay, you can try. This one is just for you to look into how the first complement are taking. You can see what is happen when you are doing the first complement. After you are having and getting your first complement, you need to add with 1 to have the second complement. If you still remember, increment by 1. Similar, there is no difference between digital subject and also COA because this one is similar method. Okay, still under recap, you can go through. That's why when you are having this, what is the objective? Detecting overflow. Okay, and overflow occur bila, which is when two positive number are added and result is negative. Two negative number are added and result is negative. So this is what you need to know. And it is also not possible to have overflow when you use a two complement notification. If positive and negative number are being added together. So there will be also a possibilities. What you learned last time, maybe we mentioned you, okay, all the digital logic subject said, sign magnitude. We cannot depend on sign magnitude because it's going to have error. That's why we need to have second complement and it solve the problem. But now under COA subject, we know By using this two's complement also, we can have an overflow or as well an error. So that's why it's come and another solution. This one an error. Ditunjuk. It's just show you. That's why we give you in terms of new aromatics things, which is fixed number on the integer. How you can apply it in terms of negation, addition, subtraction, multiplication, and division. Okay, this section examines common arithmetic function on number in two's complement representation. In two's complement notation, the negations of integer can be formed by following several flow. You need this, okay? You need this to negate your second complement or two's complement. First, you need to take the Boolean complements of each byte of the integer, including the sign. And each of it 0, you're going to change this to 1 to 0 and 0 to 1. This is first step. Second, treating the result as unsigned binary integer, and then you're going to add 1. This one is the second complement. This is the first complement step. This is second complement step. This both step you learn on digital logic subject. Okay, the example, when you have these two number, you are, okay, first you even with the 16. 16, how you going to change? This one also from decimal to binary. I hope you know. You can use on calculator also. And you need to change it. If it is 0, you need to change to 1. If it's 1, you change to 0. You can see here, everything is changes. This one is first complement. For second complement, you just add 1. You add 1, then you will get the second complement number. If you have here, you can see negative 18. First of all, you use the first complement step. For this step here, change everything 0 to 1, 1 to 0, 1 to 0, 1 to 0. And then second complement step, you're going to add with 1. So this is the answer. You will get this. This is the negation. How you can relate. From this, you're going to get negative. From negative, you're going to get another one, which is a opposite positive. First of all, if we already know and remember on the negation, we need to have the flow, which is addition, and then after that, subtraction, multiplication, and division. We go for the addition. Remember this table from digital logic subject. 0 plus 0 equal to 0. 0 plus 1 equal to 1. 1 plus 0 equal to 1. 1 plus 1 is 0. But there is a carry of 1. Okay, I hope you still remember in your mind. This is the brain. In your mind, I hope that you remember the table. Okay, by using this table, you can add two number in two's complement representation. This one is also you have done. Adding two number using a two's complement in digital logic subject. Try later on in the example. You can see you have a discharge for the carry. And this example, you can just discuss this, but you're going to get the correct answer. But in example E and F here, example of overflow that can occur whether or not there is a carry. You can see if you just remove this carry, if you just discharge it, you're going to get the error in the example. Similar also this one is negative. Supposedly you're not going to get negative number. So this is overflow, or we call as error, when we are adding the two number using two's complement. So there will be a possibility. It is in terms of additions. Now we're going to look into the subtraction. Subtraction is easily handled with the following rules. You can see here, you can have addition by changing the value here to be negative. This one is similar, right? In mathematical, let's say I have 9 minus 5. It's similar to 9 plus minus 5. So this minus 5, I'm going to change it to the complement, second complement, which is called as negation. Okay? Last time we just call it as a second complement, but now it is a negation. So subtraction numbers to complements. This is example. Here is 2. Here is minus 7. This one because you have m minus s equal to m plus minus s. So this will be, might be here is m is 2, and then you're going to deduct with 7 equal to 2 plus minus 7. So you get this kind similar to this, and now we show you on overflow. This will be also happen to get the overflow. All of this just for you to see the problem if you use the second complement only, okay? That's why after this you have another method instead of having the second complement for all these steps. Okay, now there is also a rules. Last time we didn't look into the table for subtraction. Now you need to know if 0 minus 0 is going to be 0. 0 minus 1, you get 1. 1 minus 0 equal to get 1. 1 minus 1 get 0. But for this part, it have a special case where you need to borrow 1 from next significant bits. This is a normal mathematical things. Wait, yes? Oh. Yes. Apa Iqbal? Boleh. Kalau kena. Aku kena buat slide ke? Yuk. Sorry, there is someone come to my room just now. Here's the pen. Okay, that is in terms of mathematical. Before we go to multiplication and also division, let's we take a break, 5 minutes. After this, we will continue. And might be I will call someone to do the multiplication or even a division using the second complement. Okay, we take a break first. Breakfast. Breakfast. You are the chat What is binary number? Huh? Imran?
I'm just kidding, miss. I'm just kidding.
Aduh.
Doctor,
Yeah.
can you share the module 2 in e-learning?
Okay, I do it now. Wait,
Okay, Doctor.
E-
Thank you.
okay. 09. Okay, done. You can download the module 2 and I'm going to also upload the QR code there because I can see another 4 students not yet scanned. Okay, there what here? Module 02 and also the QR code for today attendance. You can take time for downloading the module. Okay, let's start our class. We continue again. Where is it? Okay, we are until our multiplication. So multiplication, no need for me to explain. You know what is multiplication. But how are you going to multiply? Using your negation or second complement. So here is the rule. Last time in digitalogy subject, you don't learn until multiplication, until subtraction, right? You just learn addition and subtraction. Oh, sorry. Now in COA, you learn until multiplication and division. Isn't it? Last time you just learn adding and subtract. Here, you're going to multiply the number of 2 complement. And there is a table here. So in terms of this table, 0 times 0 is 0, blah, 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 blah. And no carry or borrow bit that happen when you are dealing on binary multiplication. Of course lah, when you multiply with 0, of course, every numbers will get 0. And 1 multiply 1 is going to get 1. There's no carry, no discharge. This one is unsigned integer. The normal multiplication system for mathematical. You're going to have multiplier, multiplicand, multiplier, and product. Okay. This name, please remember. Okay. This name, please remember. Because you're going to apply it in terms of the table that I show you just now last year, which is you have the flow chart, right? So you need to know where is the multiplier, where is the multiplicand, where is the product. I also already know, can't remember which one. So start from this slide, please remember the multiplicand, multiplier, and product. Over here, you have multiplicand, you have multiplier, and you have a final answer is the product. Multiplicand is n bit multiplicand and m bit is multiplier is a product, so it's going to be n plus m bit. Okay, if you got 4 bit multiply with 4 bit, you're going to get total of the product will be 8 bit, because this is the equation. If you have 5 bit, example, okay, 5 bit multiply with 4 bit, you're going to get 9 bit for the bit long for the product. Okay. So that is the statement for this part. And in just now, it's in terms of normal, which is the unsigned integer. But when you are applying with the unsigned mean, everything is positive. There is no negative, right? So when you are having signed number, of course, you're going to apply the 2's complement, which is second complement. So we already learned addition and subtraction, especially just now, and also in your digital logic subject, that it can be performed 2's complement notation by treating them. You're going to treat them to be unsigned number after, of course lah, after you already assume it as a second complement and make the process to be a second complement. So you just adding it because you just assume it to be a unsigned number. If this number are considered unsigned integer, then we are adding 9 plus 3 over here to get 12. S2 complement, there is example, okay? S2 complement, we are adding negative 7. You can see here, negative 7 and 2, 3, which is 1, 1 to get minus 4. 1, 1, 0, 0, 0. Here is 4. Here is negative. This one is 7 because there is a overcharge here, carry. That's why you get 1. The rest will be 0, 0. Maybe you can try to change 7. You change to binary 4, 5, 6, 7, 7. And then the change is to be 0, 0, 1. This is the first complement, isn't it? This one is from decimal to binary. Am I correct? 0, 1, 1, 1 is binary for 7 decimal. Convert it. Hope that you still remember. And then for first complement, you just change. If it is 0, you change to 1. If it is 1, you change to 0. You get this part. After that, for second complement, what you need to do, just add with 1. That's why you get 1, 0, 0, 1. which is the second complement number, -7. Okay. Unfortunately, the simple scheme will not work for multiplication. See, it's already mentioned. You cannot use this in the multiplication. You can try to use the example there. That's why normally we will get incorrect result. Tak perlulah I panjang lebar. That's why we getting error and error using this second complement, using using our multiplication process and division. That's why we will come up with the solution. We're going to learn using multiplication algorithm. There is algorithm for you. A multiplication algorithm and hardware. Okay, a multiplication can cope with overflow error because we frequently want 32-bit product and a result of multiplying of 2-bit number. Okay, now I show you just now. No need for you to remember this, okay? No need for you to remember this. You need to know the name of the algorithm. The name of algorithm is what? First versions of multiplication hardware. But you need to remember this flowchart. If you don't remember, it's okay sometimes. Because normally in test, maybe you can ask me first before test, Doctor, is it this flowchart will be given? If I said yes, then no need for you to remember. But you need to know how to apply this flowchart. Maybe you don't know. Adding multiplication. What is multiplication? To product. What is this? So you need to know using this flowchart. Okay. You're going to start with, of course, two numbers, which is multiplier and multiplicand. That's why I ask you to know what is multiplier, what is multiplicand, and what is product. Okay, I'm going to bring this flowchart to the next. Oh, I put here already. No. Okay, for this example, it's got here. But after that, it's done. So I'm going to copy. I'm going to put here. Mana nak letak ni? Maybe too small. Okay, here. Now I go back to the slide. Okay, please make sure you remember, okay? Now we look first example before we go to the table. We were given with two number multiplication process. 2 times 3. Normally, it is very easy. Anak saya pun tahu jawab ni. It is 6. But in terms of binary, you need to convert first to binary. Okay? You need to convert to binary. And you need to know where is multiplicand. We call this MC. Where is multiplier? MP. Where is a product? And you're going to put all these in terms of this table. Okay, in COA subject, normally this question will be coming for your part B. Okay, for part B, and our question will be close embedded. Close embedded means we give you the table. We give you the table. Maybe we just put P, MC, multiplier, and P only. The rest is empty. So you need to fill in. But if you are lucky, we just give you a drop down. Okay? You just pick which one is the answer. But you need to know whether this part need to be answered or this part. Okay? Some of it just empty. no and nothing, which is empty. So that's why you need to know which part that you need to put. Because like this, for shift and shift this one, you just need to shift MC. You just need to play around with this part. No need for you to fill in something here. No need for you to fill in something here. So if for step number 3, you only play around with this area, no update here. So that's why you need to know how to apply the flowchart here. Okay, now we have 2 times 3 equal to what? This is MC, this is MP, and this is a P. First of all, what you need to do? Test multiplier 0. How to test? What to test, which is if the multiplier is MP. If your MP 0 is what? Bit 0. Okay. This is bit 0, bit 1, bit 2, bit 3, bit 4, and so on. Okay. If the bit 0 here, the start one, which is your LSB lah senangnya. Your MP LSB is 0, you need to go to the right. If your MP LSB is 1, you need to go to the left. Okay. What will happen here? You need to add multiplicand, which is your MC, to your product, to your P, and place the result in product register. What does mean by this? Let me see at the example after this. And for this part, if, okay, for this one, our question here is going to be flow here, right? We're going to do this as 2 times. You can see here. Because we're going to refer, sorry, first time is going to be 0, because digit 0. And we will go to his shift the MC to the left 1 bit. Okay, what is meaning by this? And then your multiplier, which is MP, shift to the right. You need to check. This is not until 32, okay? If your digit is 32, then you need to check whether you already repeat 32 times or not. But our digit is only 4 bit. That's why only 4 times. Okay? It is, if it is below than 4, you're going to repeat until you reach 4 times, then it's done. Okay, let me see the example. Okay, there is a step-by-step here, which is this one at the flowchart. Now we have the similar question at previous slide. Okay, at this previous slide, we have 2 times 10 equal times 2 decimal times 3 decimal. Okay, this one is your MC. Okay, our MC, where is it? This is MC 0, 0, 0, 0, 0, 0, 1, 0. Okay, 2 decimal. Where is our MP? Our MP is here, and you need to take note. It is only 4 bits. Okay, need to apply that after this in next question and etc. You just apply the as thing here. But for MC, it's going to 8 bit. Okay, 4 bit here, 8 bit here. And this is 3 decimal. How about your product? So your product, you're going to first initial, you don't have anything. That's why you put 0, 0, 0, 0, because you don't know yet. Second, of course, you're going to bring it down here. And then, sorry. Okay, first of all, you're going to test a multiplier, which is your MP. Is it your first is 1 or 0? Now you're going to see it is 1. So you need to go to add multiplicand, which is your MC, and place it to the product register. You kena tambah ya. This one, add with this. 0, 0, 0, 0, 0, 0, 1, 0. Senang lah sebab this one is 0, right? So you're going to place your answer here like this. Okay, for the step 1A. Why this one is empty here? We're going to make a scroll button for you to select whether what is answer for this part. Normally, sometimes here also we will ask you to select. Okay. Next, tak cantik. Okay. Next we have here 1A P equal to P plus MC at here, okay? So this is the answer for 1A. After that, where you going to go? You're going to go to 2. 2 mean shift MC to the left. Where is MC? This is your MC. You're going to move 1 bit to the left. So mana you nak move? Ini you're going to go out. It's already kicked out there. And here will be moved to this. Here will be moved to here. Here will be moved to here. Here will be moved to this. Now you have here, this will be 1. This will be 0. And of course, there is no number. You put this. So you move to the left. Hey, this one should be here, okay? Sorry. Okay, so in a beautiful way, this will be here. This one shift to the left, kick out already. Okay, you need to know how to shift. Now, nothing here, so you will put as a 0. Okay, this one is very important because every test, every year, every SEM, it will become out. Just changing the value. Okay. Next, we have finished this step. Step number 3. We're going to shift MP here to the right. Similar happen. This we kick to the right. We kick already. This one we will put to the right one. This will be put to the right. This will be put to the right. And nothing here. We will put 0. That's why you will get 0, 1, 1, 0. You can see empty space here. That's why I mentioned some part is empty. So you need to know and correctly fill in at the table. Although we already give you the table, mostly you write in the wrong column, you get also wrong answer. Although your step is correct. Okay, although your final answer, of course, lah, you know this one is 0, 0, 0, 0, 0, 1, 1, 0. Although you know the answer, but your step wrong box, also you get error 0. Okay, next. After that, we can see it's just one time, isn't it? We compare. Is it already 4 bit? 4 times? No, you need to go up. Now you test again. This is your MP for the digit 0. Is it 1 or 0? Still 1. What you need to go? You need to go to 1A. So if you want to go to 1A, what happened? You're going to add this value, your MC, with your P now. Oh, apa jawapan dia? Someone help me? 100. 0, 1. Sorry. 0, 1, 1, 0, 0, 0, 0, 0. Alright, right. When I add these two together, I will get this one. So this is the current P for me for step 1A. Okay. So this is the answer for 1A. Now, after I finish, I will go to the step number 2. For step number 2, what happened? I'm going to move my MC to the left. So here I kick this one. Here I will put 0, 0, 0. Here will be 0, and then here will be moved to here. 0, 0. And nothing here, I put 0. Lah, salah tempat lagi, nampak? It's supposedly to be here. Okay? So that is the answer. You can see it's already moved here, and you already add another 2, 0. And now, number 3. Shift to the right. You kick this one to the right. And what will happen? 0, 0, 0. And there is nothing here. You put 0. That is the answer. Now repeat again because you just 2 times doing this. What are you going to do? You naik atas kepala. You're going to go up, back, and you're going to see the 0 multiplier, your MP digit 0. It is 0 now. Okay, I'm going to go to the right now. No need for me to do 1A. Okay, if no need for me to do 1A, I just left this as the answer that we see here. Nothing I'm going to put here because no operation. Okay, no operation. You just directly go to the number 2. That's why here will be empty. Okay. Then you shift left. Sama juga. It's similar. You shift left. This one you kick. This one you kick to the right. You're going to have also 0, 0, 0. And you repeat again because it's just a number 3. 3 times. You repeat and check. What is the digit 0? It is also, someone is typing in the chat. It's going to get 0 there. And then you're going to go to the right. No operation again. You didn't do anything here. You just do the next second step. Second step, what you're going to do, you move to the left, isn't it? You move to the left, kick this one. To the left, here will be this one. 1, 0, 0, 0, 0, 0. Here, you need to kick to the right. Also 0, 0, 0, 0. Okay, so the final answer will be like this. This one is also important, although you already get the answer. See here, you get the answer. Because suddenly, your multiplier, which is your MP, sometimes you get 1 here. Sometimes at the beginning, you have 1. So you need to do again 1A and etc. So that's why you need to follow basically how many bits you have and do it. If it is in terms of multiplication, it's quite easy. You can see step easy. But sometimes when you have negative number, what happened? Alhamdulillah. It's going to be quite complicated because you need to change the negative number first. Then you will find out where there are a lot of 1, 1, 1, 1 there. Your addition also will be much more complicated because let's say you have 1, 1, 1, 1, 1, 1, 0. At the end, you're going to get 1A. You add again. So you will have like a carry and etc. How are you going to apply with that? Although you can see, senang je ni. You can see and follow the step. But as mentioned, we will going to change the number only. But when it's applied with negative, it's much more complicated. And also the similar things will happen, but a different way for the flowchart for the division. Okay, any question? Mana chat? Kenapa tak nak cakap? If multiplier 0, then do not addition of MC and P. If multiplier is 0. Yes, if not the multiplier is 0, the digit of the multiplier. We just look at the nak punya pen ni. Okay. It means the multiplier, first version of multiplier is looking at bit 0, not the multiplier is 0. Okay, your sentences is like multiplier is 0. The bit of multiplier, the bit 0 of multipliers, the bit 0 for multiplier, if it is 0, then you need to go to the right. If the bit 0 of multiplier is equal to 1, you need to go left. Left, if the bit 0 is 0, you go to the right. Left, you go do 1A. Right, you do step number 2. Okay, understand? Okay, the bit 0 is LSB, okay? Don't do MSB. Okay, that is the answer for you. After that, you're going to have example and exercise, especially for the solution 2. Please make sure exercise 2.2. Please try to do it. I will give you a solution also, but before I give you a solution, done and do it by yourself. Fill in the table. Imagine if you were given only this empty side. Are you going to put a correct box? Just now also, I always write in the wrong column. So I hope that you can write in the correct column and you can get the answer correctly also, okay? Because this type of question, it always asks you in part B, and it quite huge, might be 8 or 10 marks for just a simple one question like this. Okay, any other question? Lagi? Okay, so we go, if there is no question, because that one is very easy, right? As I mentioned, it is a positive number. What happen if you have negative? That is just now I show you. If it is negative, what happen? Okay, for multiplier, if the MP, there is a rules and regulation. The multiplier, your MP, must always positive number. Kalau, okay, kalau your number here, jauhnya. Okay. Mana dia tadi? Okay. Kalau your multiplier, if this one is negative, let's say you were given 5 times negative 5. Multiplier is negative 5. What you need to do? You need to change the place, okay? You need to change the place because multiplier cannot be negative. Betul tak I punya instruction? Okay. Multiplier need to be always positive. Do additive inverse for the multiplicand MC and the MP. If you are finding this kind of example. Multiplicand times negative multiplier, you can do the additive inverse, which is equal to minus multiplicand. This one you also can apply. You can also change the place. MC times minus MP equal to minus MC times MP. So just now, if you have 7 times minus 5, you change this to be minus 7 times 5. Because your MP here supposedly to be always positive. Okay, like our self lah, we need to be always positive. If this one is not a problem, because you know negative times negative, you're going to always get a positive. So you need to remember these rules. You need to apply it. What else? This is an example using 4-bit binary arithmetic. You need to multiply 2 base 10 with minus 3 base 10. This is negative. So what you need to do, you need to change it, this negative, to your MC using the first versions of the multiplication hardware, the flowchart there. That's why I ask you to remember the name. Do additive inverse. From here, change to this. Using, and you're going to do the same. Okay, over here, I'm going to go speed a bit, okay, because we already look into one by one just now. Just now the question is minus 3. We change it to be minus 2. This one, you cannot just apply minus 0, 0, 0, 0, 0, 0, 1, 0. This is 2, right? In binary. You cannot just put like this, okay? Instead, you need to change it using your second complement. Yang ini pun no need for me to do again. You can try to do because you already learned just now and you already learned in your digitology subject. Okay, why? This one is getting like this. This is a second complement to appear and shows this as a negative 2. This is 3. And our product initially will be 0. Look into this 0 bit for MP. If it 1, there is a 1A. What happened? You're going to add this with the product. You're going to get the answer 1111 1110. Then what you're going to do? Left 1111 1100. Here you're going to move to the right 0001. And you check again, what is your MP digit 0? It is 1. So you need to do 1A again. And followed by, later on you will get 0000. Currently, there is no operation. And etc. Okay, for this part, 0001. What you need to do, you're going to add. This is the one that I mentioned just now. You're going to add this P with your MC. What happened? Your MC currently is 1111 1100. Then you need to add to get the answer here. 1111 1100. Try to add, then you get the answer. Please try to do it. Later on, I give you the solution. Okay. There is also another example, example 2.3. Jangan pergi cari dekat video ya. YouTube, because I already give the solution last time for several semester for all these example and also solution. Try to do it. You can see the difference now for 2.3. For 2.2, you have 4 bit only, similar to your 2.1. 2.3 is 6 bit. That's why you punya tables going to be quite long, because you're going to reach until 6 times. That is the only difference, similar to the value here. This one is positive. No need for you to scare with. If it is 6 bit, you can see you're going to have 1, 2, 3. Okay, just now if it is 4-bit, you're going to get add 1, 2. Now you have 3 until 12. For MP, it's going to be 6. So that is also the difference. It's quite long. So exercise 2.4, you can try also. And now we're going to go to division. Before we move to the division, any question for our multiplication? Semua tak ada question means that I nak use score 4 mark, okay, if this kind of question coming up. Now we go to division. Division, you bacalah description ni, blah 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 blah, because I think description is not too hard to understand. The most important in terms of the flow just now after this. Okay, before we go to the apa nama dia algorithm, before we go to this algorithm, you need to know why we need that algorithm. Okay, so we have normally when we are doing and dealing with mathematics, we have dividends, divisor, and quotient, also reminder. So you need to know all of this. Similar also with your current just now we have multiplication, we have the MC, MP product, isn't it? Similar also for this one, you need to know where and where is the dividend, where is the divisor, where is the quotient, and where is the remainder. Okay, this is the normal mathematically. And another way for you to represent by this normal mathematical form, you can also having like this, because this mathematics, if you have the divisions here, you can move to the right and be multiplier, isn't it? And then you have the adding on remainder. This is a normal mathematical. You learn it in your secondary school. And next, if the remainder is smaller than, okay, this one is where the remainder is smaller than divisor. Semut! Bilik saya banyak semut. Tiba-tiba kan. Wait, I had this mole in here. Okay. We go to this, how our mathematical for unsigned integer. Unsigned is not a problem for us because it is a normal mathematical we learn even from our standard 2, I guess. Standard 2 we already start learn on the division. But now we are applying in terms of binary number. That is all the unsigned. But for the signed integer, you need to apply second or 2 complement. For the 2 complement, you can see you need to remember these rules. Okay, there is a rules for you to remember. If positive and positive, what will happen to quotient and remainder? If a positive, negative, what will happen to your quotient and remainder, and etc. So negate quotient is the if dividend and divisor were on the opposite sign. So that's why sometimes there is a problem related to your second complement similar to your addition, subtraction, multiplication. You need to have another new algorithm for you to come up with direct answer. So here is similar, but just now is first version of multiplication hardware. now it is a first version of division hardware. And here is the flowchart. Is totally different from just now. You have several methods and the repetition is +1. Just now, if you have 4-bit, you need to compare with 4-bit, right? But here, if it is 4-bit, you need to repeat until 5. Okay? That is the first things that you need to know in terms of this flowchart. Okay, if you have given with this, using 4-bit numbers, you need to divide 7 with 2. So where is your dividend, which is DD? Where is your divisor, D? And where is your quotient, Q? I tak copy. I need to copy to this part. Mana dia? Okay, I'm going to put quite small, but I hope that you can see. Okay, now, if you were given with this question, you need to know where is the D, where is the R, where is the Q, isn't it? So here you have slightly different, especially look into this divisor. Okay, just now for you, this one is your MC. You can see the value if you were given with 2. Okay, if you were given with 2, what you're going to put like 0, 0, 0, 0, 0, 0, 0, 1, 0. But now for division, you need to swap. Okay, you can see here. You need to place this at the right and this is at the left and this is at the right. This one is important for you, okay? You need to put it here. This is your divider. And for your R, just now you can see here your R. Nowadays, first initial value, you don't give it anything, but you need to know it's going to be reminder. Just now we don't have anything, but we're going to put it as 0, 0, 0, 0. You're going to see step number 2, kecil sangat lah. Subtract the divisor register from the reminder, which is the one that you put here, and place the result on the reminder. Okay, first of all, you have 0, 0, 0, 0 because there is nothing, but you're going to subtract it, then that's why you will get the answer just now, which is 0, 0, 0, 0, 0, 1, 1, 1. Okay. I repeat again, you're going to use subtract the divider. This is your divider, which is 2, from the reminder register and place it in the result. This is step number 1. Over here, you're going to divide this with, you're going to divide with this and this one. What is your answer? You're going to try to divide, you will get this solution. And then you're going to compare to see whether your reminder is more than 0 or less than 0. For here you can see this is a R equal, okay, this one is R minus D, R plus D minus this one you need to do in terms of second complement, get this result. And then you're going to do 2B because you are less than 0. what you're going to get here is negative. And you will shift to the left. Your Q, you're going to shift to the left, but there's nothing happen because it's a 0. And after that, you're going to have the value of mana I punya pergi? Flowchart tadi. Where is my flowchart? It's already gone. And then after that, you're going to do the step of number 3, which is shift to the right for the D. This will be moved here, this will be kick, this will be shift to the right, and you need to put at the specific box here. And you're going to do it together again, similar to previous time for your multiplication. You can see you're going to repeat. For now, if you are having 4-bit, you're going to add until 5. Repeat again until 5. That's why you're going to see there is 5 altogether for this step. Okay, try to do it because this one we already provide with you the answer. And there is also several exercise later on. You can try to do it also. It's quite similar with the multiplication one. Okay, we're not going to cover until floating point. You can try to do the exercise. Any question? Any question related to this? Because it's good for you to do many exercise as this is the confirmed question that will coming up. Bukannya ya like you going to like what type of question can be asked? No, this is direct question. The only difference is in term of the number. Okay, only the number will be different. The rest is going to be totally similar. And it's confirmed to become up. Okay, any question? If you don't have any question, we can end our class. Lama tak nampak. Sekejap. Kenapa tak nak cakap? If multiplier is 0, total for the iteration 0, what is the value is? Oh, where is the example just now? Wait, Mana soalan dia tadi? This one is multiplier. Sekejap, wait. Multiplier. Division. Okay, now is division. Okay, just now the example showing you that it is a reminder if it will be 0, 0, 0, 0, 0, 1, 1, 1. This is basically took from this. Here we'll be putting at the initial point, and this will be putting at the divider, and your quotient will be putting here. So it's slightly weird. You need to know quotient is 0. Okay, quotient is 0. This is initial value. Just now for multiplier, the 0 part, which is, you don't know, right? Like 2 times 3 equal to what? It is putting here at the P, isn't it? But your quotient now is putting at this column. And your initial value that you are trying to divide with, you're going to put at reminder. Okay, so here we'll be putting, serabut dah. Here, you're going to put as a R. Here, you're going to put as the D. And the one that you don't know, you're going to put at the Q. This is the initial value, is 0. And for the multiplier, 7 multiplied with 2 equal to, you don't know. So it's slightly different. This one will be P. P will be here. This will be your MC. This will be your MP. Am I correct, this one? Maybe I switch that. But this will be at here, which is 0, 0, 0, 0. Supposedly it's going to be at bit. This part will be here, and this part will be here, isn't it? I didn't switch this thing right. So the one here for divisions is slightly different, similar also at the divisor. It switched together, similar on this one, it switched the place. Okay. Initial value. Okay, ada question? Mana lagi? I think you can try to do exercise. This one is give solution. But if you look at my YouTube, maybe you can find out the solution. So before you can try to look into the previous section video, why don't you try to do it by yourself, okay? Okay, it's already 4 o'clock. Okay, thank you everyone. If you have any question, you can ask me directly also. Meet again next week. Before next class, I will pick anyone, okay, to explain about the example for multiplier and also division. Jangan cakap you tak buat. Apa lagi? Do I get extra mark for self? I didn't get anything for the YouTube. I'm not the YouTuber. So no extra marks. I also did ask you to subscribe to my channel. Okay. Thank you. Meet again. Please be safe and bye-bye.
Thank you.